Okay, let's dive into the Agent2Agent protocol A2A. It sounds pretty ambitious. Google and what, over 50 partners are behind it?
Yeah, exactly. And the goal isn't small. They're framing it as the potential HTTP of the agent internet era. We really want to focus today on the technical nuts and bolts and, importantly, the results.
Right, the quantifiable benefits. So, what specific problem is A2A actually solving? Because agent integrations existed before, right?
They did, but they were messy. Think custom-built APIs for every single connection. If you had an agent built with LangGraph needing to talk to one using Crew AI, well, good luck. It was fragile, didn't scale, just didn't work reliably.
Okay, so A2A steps in as that universal translator between different agent types. But hang on, isn't that what the Model Context Protocol, MCP, does? I hear that name thrown around too.
Ah, good question. No, they're different. Really important distinction. MCP, the Anthropic-backed one, that's about how one agent accesses tools and data. Think of it like giving an agent a better toolkit. A2A is purely about agent-to-agent collaboration, how distinct agents work together on a task. So they're complementary, not fighting for the same space.
Got it. Okay, that clarifies things. So let's get into the A2A architecture. I read about this design principle, opulence of opacity. Sounds intriguing. What does that mean in practice?
It means agents can work together without spilling their secrets. They remain, well, opaque boxes to each other. Your agent doesn't need to know the internal code or the specific memory setup or the exact tool implementation of the agent it's collaborating with.
Which is huge for protecting IP and data privacy, especially in business settings.
Absolutely crucial. So if they're opaque, how do they actually communicate reliably? What are the core technical pieces?
Yeah, what makes it work?
Three main things. First, the agent card. It's basically a JSON file, like a structured resume for the agent. It tells other agents what it can do, what version it is, how to authenticate capability discovery, essentially.
Okay, standard ID card. What's next?
Task management. This is vital. A task gets a unique ID, and it has a defined lifecycle. Submitted, working, completed, maybe failed. It provides structure for complex jobs that might involve multiple steps or agents.
Right, you need that tracking. And the third piece,
Artifacts. These are the concrete results. The document, the structured data, the image, whatever the remote agent actually produces while working on the task. It's the deliverable.
agent card, task management, artifacts.
Okay. And technically, how is this all implemented? Is it brand new tech?
No, and that's a smart move. It leverages existing trusted enterprise standards. We're talking HTTP, server-side events, SSE, and JSON RPC.
So it plugs into existing IT infrastructure more easily.
Precisely. Less friction for adoption. And security is built in from the ground up. Secure by default is the principle. It supports things enterprises demand, like OAuth 2.0, SSO, MFA, and end-to-end encryption is mandatory. Okay, let's talk about complex tasks. Things that don't finish instantly, maybe something takes hours or even days. How does A2A handle that without connections just timing out? That seems like a big technical hurdle.
It is, and A2A addresses it directly. For real-time updates and results trickling in, it uses server-sent events, SSE. So the calling agent gets continuous feedback.
Like streaming results.
Exactly. And for the really long-running stuff, tasks that might take ages, it supports push notifications. So even if the client disconnects, the system can push an update when the task is finally done or hits a milestone. That flexibility is key for automating serious, complex workflows.
And this technical design, this robustness, it translates into actual business results, right? I saw a case study from a large company. The numbers were pretty staggering. Customer service efficiency up by 300%.
Yeah, 300%. And that stability we talked about, they hit 99.99% availability with average response times under 100 milliseconds. That directly cut operations response time by 80%, which in turn led to a 60% reduction in operations costs. That's the payoff you get from replacing those fragile, custom, point-to-point integrations with a solid standard. Huge technical and financial wins.
Okay, so the protocol itself sounds very well thought out, secure by design. But like any system, the implementation matters. What's the critical thing to watch out for if you're building with A2A?
Absolutely. Implementation is key. The biggest risk isn't the protocol. It's ensuring your backend systems rigorously verify roles and permissions asserted by an agent. The protocol itself is sound, but you still need proper checks and balances.
Right. Which leads to a final thought for you, the listener. Why does this back-end verification matter so much? Because even with A2A standardizing things, if you're not careful, prompt injection could still be a pathway for abuse. Imagine an agent whose agent card claims it only needs calendar access.
Ah,
If your orchestrator doesn't properly verify those limited permissions on the back end, that agent might trick it into performing actions far outside its scope, like booking expensive flights it shouldn't have access to.
it's exactly. The HTTP of the agent internet era still relies fundamentally on robust identity verification at every step. That's the crucial takeaway.